Hello to everyone. Let's talk about the diagonalization of a matrix. So matrix A, it's diagonalizable when it's equal to the product of a matrix X times matrix D times inverted matrix of X. Diagonal matrices are relative easy to compute. Let's have this matrix and see if it's a diagonalizable. So we'll have first to find eigenvalues and eigenvectors. So we have this matrix, and to find the eigenvalues we need to use the formula. So a matrix A minus lambda times identity matrix we have here, and we end up here having lambda in the main diagonal and 0 in other entries. So now we subtract the result of this operation. So we'll have 1 minus lambda 7 0 2 minus lambda, and now we can have the determinant of this matrix set equal to 0. So here we will have a question, and this question will come from multiplication of 1 minus lambda times 2 minus lambda plus 0 times 0, so equal to 0. Now we can 1 times 2, 1 times negative lambda. We can have negative lambda times 2, negative lambda times negative lambda, and here they will be 0. So now we can simplify this equation, and here we can reward it. So here we have the quadratic equation. So we have to factor it, and to factor it we need to find the two numbers that multiplying it's equal to 2, and the sum is equal to negative 3. So negative 1 and negative 2. Now our first lambda will be equal to 1, and the second lambda will be equal to 2. So this is our eigenvalues. Now let's find our eigenvectors. So we have this equation. We will have A minus lambda times identity matrix all multiplied by x vector equal to 0. So we have here the matrix A, and also the lambda 1 and lambda 2. We will have to plug in this value in this equation. So we plug in first, we start by 1, we plug into this equation, and here we will have 1 a matrix minus 1 times identity matrix, and we have here, we end up here with 1 1, the result of the product of this multiplication, and here we'll have this matrix A matrix minus the product of this operation, and we will have here 0 7 0, and 2 minus 1 will have here 1. So here we have, and we can have we have to remember that we are solving this equation, so we will multiply this product by x matrix equal to 0, and here we'll have, as we have 0, here we have 7 times x2 equal to 0. Here we have 0. Here we have x2 equal to 0. So we have x2 equal to 0. We can choose any number for x1, and here we have our eigenvector for lambda 1. Let's see, have our eigenvector for lambda 2. So we plug in here 2, and we will end up have 2 in the main diagonal and 0 in the other entries. And now when we subtract, we will have here minus 1, we have 7 0 and 0. So now we multiply by this x matrix equal to 0, and here we will have negative 1 times x1 plus 7 times x2 equal to 0. So, and now we can have move 7x2 to right side and multiply all by -1. We end up have x1 equal to 7 times x2, and our eigenvector will be 7 1. So now we have this value. We can recall again to see if the matrix A is diagonalizable or not. So we have, let's look what we have. We have a matrix A. We have a matrix D. 1 and 2, it's the eigenvalues that we found. So we found for lambda 1, for first lambda we found 1, and for second lambda we found 2. We have eigenvalues to form our diagonal matrix, having eigenvalues in the main diagonal and 0 in other entries. Also, we have our X matrix. So X matrix come from the eigenvectors that we found. We have eigenvector has a coulombs of X matrix, and now we need to find the inverted matrix of the X matrix. So we have here X matrix. First, we will calculate the determinant of the X matrix. So we have 1 times 1 minus 7 times 0. And this we will have now 1, 0 equal to 1. And now we will switch the values in the main diagonal and multiply other ends by -1, and this result we will divide the determinant. Inverted matrix will be equal to 1, -7, 0, and 1. And now we have all the metrics that we need to prove that the matrix A is diagonalizable. So now what we have to do is have the product of this operation, and here we have matrix X, we have the diagonal matrix, and we have the inverted matrix of matrix X. So we start by have the product of these two matrices, and we will have 1 times 1 plus 0 times 0, 1 times -7, and 0 times 1, and we will have 0 times 1, 2 times 0, and 0 times -7 plus 2 times 1. So, and now we can simplify. Here we have 1 plus 0, have -7 plus 0, 0 plus 0, 0 plus 2. Now we have to find the product of this operation. So we have 1 times 1, 7 times 0, 1 times -7, and 7 times 2, have 0 times 1 plus 1 times 0. We'll have 0 times -7 plus 1 times 2. So, and we can have here 1 plus 0, can have here -7 plus 14, we can have here 0, we can have here 0 plus 0, we can have here 0 plus 2. So we have here the result will be 1, 7, 0, 2. And we found the product of this operation, and we see that it's equal to 1, 7, 0, 2, and also the matrix A, it's equal to 1, 7, 0, 2, and we can confirm that or we have proved that this the matrix A is equal to the product of X times matrix D times invert the matrix of X. Thank you for watching. Please don't forget to subscribe and like this video for more content like this.